Hey guys, John here again with Showed Engineering and Performance. I've got a 6.7 Cummins here that I machined on about a month or so ago, and it had an oversized sleeve in it. So it had already been machined before, and that's usually no concern really to us, because even if the deck's been taken down, we can take down the deck and clean it all up, and we can make compensation for that in the head department. And so we wanted to use this block, and so I got the old sleeve out. We realized that we didn't have any sleeves that were large enough outside diameter to go into it, so we got a custom sleeve made. And by the time we had a custom sleeve made and everything, I got it and started to machine on it again and made my cuts to make the precision fit, because you have to have a precision fit, an interference fit for the sleeve to go in. And when I got to the point of making my final cuts, I realized that this was not going to clean up, because whoever had machined this before machined it not at a perfectly straight line towards the crankshaft. And so when I made my cut, it didn't line up with the last person's cut. And so I had a nice round cylinder at the top, and then it tapers off at the bottom because I missed. I'll show you what I'm talking about here. So you can see here in the cylinder, you can see the marks that my cutter made. It was a little bit of a dull blade. But as we go down, you can see where it's not touched at all. So we're already pretty much at our maximum cut here. If we go out any further, we risk some really major issues down the road for this engine. This cylinder is already pretty much machined at its max, and so we can't use this block again. But I'll show you how we go about making sure this doesn't happen when we're machining, so that everything is nice and straight and in line with the crankshaft, and you have no issues at all from that. All right guys, so we're back here with a fresh 6.7 block that's come to us. I've got it cleaned, and the main bores are main bores are already measured and everything's within specs, so I'm good to go ahead and machine this. And I wanted to share with you our process of making sure that everything's in line, so we don't have that issue like we saw just a minute ago. So these are locators. These go in our main journals. So this one would go right here on this one, and then this would go on the other side. The issue with that is once it's in our machine and on the 4th axis, there's a little bit of tilt with it. And I'll show you when I get this in the machine what that looks like. But the way that we get across that, this is a cam locator. And so with each engine, each different model type of engine, you have to have the right cam locator, because if it doesn't fit, then you're not going to have the benefits of this system. So this is the right one for this particular engine, and we know that. It's a little bit tight, but it goes in there. There's a little bit of give there, and so I know that's the right one. There's just a tiny bit of shimmy to it. And so when that's in, there'll still be a little bit of give with it. So what we do, we have this bolt that goes through here, and that's that taper there, and this bolts into the back of the 4th axis, and as it tightens down, this expands out. And so what that does is a couple things. One, it brings everything nice and tight, but as it's bringing it tight, it's also bringing it to a place where we know that the cylinders are going to be perfectly in line with the mains and with the crank. So we know when we're machining everything that everything's perfectly right and in line. So the reason why this is important. So when you're driving down the road, when you have your engine running, your crankshaft is rotating, and your connecting rod, your pistons, all of that, your pistons are coming up and down, up and down. So imagine, as your pistons are coming up and down, if the cylinder is just slightly tilted that way. All right, and now your pistons are coming down, because you're going to have a lot of wear here, and you're going to have wear on your cylinder wall, you're going to have wear on your pistons as well. That's going to not only create problems for the longevity of the engine, but that's resistance, that's drag, that's working against the rotation of the engine. So that's a loss in power, performance, horsepower, all of that. And so it's absolutely imperative that when we're machining these blocks, that we get everything nice and straight and in line. And so with our V-type engines, with our Duramax and our Power Strokes, we know that everything is perfectly in line because we've got the cam locator where it needs to be. Here with this, we know 38 degrees off of this is where we need to be. And so this is how we kind of avoid doing what happened to that block over there and getting things all crooked, and nobody wants a crooked cylinder wall. We want things to be nice and straight.